Here's 2017 question 6. This is definitely a miscellaneous problem. Doesn't mean that it's not important. It's just they focus more on the analytical stuff, such as knowing how to take derivatives or take integrals using a variety of rules. Okay, so here I noticed that they give us the graph of h. Let me use a different color there. Okay, and then the table here is a bunch of g's and g primes, so that's a little bit awkward. And one more fact here, they mentioned something about f. Okay, so a lot of things that they're giving it to us, but let's take it one part at a time. Here we go. So part A, find the slope of the line tangent to the graph of f. Okay, slope of the line tangent means derivative. Notice how they don't ask for the equation of a tangent line, okay? So what is the slope of the line tangent to the graph of f at x equals pi? Okay, so we're given f here. So what's f prime of x, okay? Notice how cosine of 2x, there is a 2x inside of your cosine, so it's going to require the chain rule. So that's the derivative of the outside of the same inside times derivative of the inside, okay? Plus, now e to the sine x is also another composition, a function within a function. So derivative of the outside of the same inside times derivative of the inside function. Okay? So we need to find f prime of pi. So this is negative sine of 2 pi times 2 plus e to the sine pi times cosine of pi. Equal is equal. You can leave it like that. I believe the scoring guidelines goes all the way through, but who cares? We don't need to. Okay? Here's part B. Let k be the function. So they introduce a new function k, where k is h of f of x. Find k prime. So here, h of f of x looks a lot like a function in a function, so we have to apply the chain rule here. So the derivative of k is really just the derivative of the outside of the same inside times derivative of the inside. Okay? So now that I know k prime of x, well, k prime of pi is h prime of f of pi times f prime of pi. Okay, so what the heck is f, right? F of pi, you're given f here. Now, you could leave it in the abstract answer, but just so that it kind of matches up with our scoring guidelines, if you plug in pi, you'll get cosine of 2 pi plus e to the sine of pi. Cosine of 2 pi is going to be 1. Sine pi is going to be 0, and e to the 0 is just 1, so that gives me 2. Okay? Pause, go back if you need to, okay? That's going to be h prime of 2. F prime of pi is what we did in part A, so I'm going to cheat a little bit. Going back to the scoring guidelines, this comes out to negative 1. So that's really just that's really just negative 1 here. Well, what's h prime of 2? So we're given the graph of h, so there's a lot of, I guess you could call this an analysis problem here, okay? H prime of 2, now 2 is right here. Now we're not looking at the location because that would be h of 2. They're asking for h prime of 2. So remember, h prime of 2 is really just the slope at that moment. So notice how this belongs on this line right here. So if I just use rise over run, which I think is the easiest, we go down 1 over 3. That slope right there is going to be down 1 over 3, negative 1/3, which is what you see in the scoring guidelines, okay? You can multiply this out, equals equal, I'll leave it there. Okay? Here's part C. Let m be a function. So we have a new function, m, but it's going to be g of negative 2x times h of x. Okay, they want us to find m prime of 2. So before we find anything regarding the 2, let's find just the derivative here. Since we have a product, we're going to have to implement the product rule. So it's going to be the first times derivative of the second plus the second times derivative of the first. Let me make some space here. Derivative of the first. The derivative of g of negative 2x is a composition. So we actually have to apply the chain rule here. So that's the derivative of the outside of the same inside times derivative of the inside. Okay, so they're really looking at technical details here to see if you truly understand the rules. Okay, here we go. We're looking for m prime of 2. So let's plug in 2 here. That'll be g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. Okay, so what's g of negative 4? G of negative 4, according to my table, is going to be 5. So I'll plug in 5 here. Since I'm already talking about g, let's look at g prime of negative 4. That's going to be negative 1. Okay, h prime of 2, we figured out earlier in the last part that it was negative 1/3. And did we figure out what h of 2 is? Okay, h of 2 is going to be that coordinate right there. Now, how do you actually figure out that coordinate? Right? So, many ways that you guys could do it, but here's the thing. If you look at the slope, it's going down over 3. So, it's going down over 3 or going down 1/3 of the way over 1, 1/3 of the way over 1, 1/3 of the way over 1. Okay? So there are a lot of ways to analyze this. I really don't know what the easiest way would be. It kind of just depends on you. But notice how I went down 1/3 twice. So I know that this is going to be negative 2/3. Okay? There are other ways, but I'm not going to go over that. All right? So this will be negative 2/3. That's enough for equal is equal. Let's move on to part D. Is there a number C? So before I continue, the fact that they're asking you, is it possible? Does there exist? Is there a number C? Right away, I'm thinking about my 2 theorems, either IVT or MVT. Okay? Is there a possibility such that the derivative of g comes out to negative 4, somewhere in between negative 5 and negative 3? So somewhere in between negative 5 and negative 3, is it possible for g prime to hit negative 4? Okay, so a lot of people, what they would do is they'll take a look at g prime itself. And g prime is traveling from negative 3 to negative 1 to 4. So right away, people think there's no way that it's guaranteed to hit negative 4 according to IVT. So here, IVT is not guaranteed because of the way that it's traveling. There's no possible way to guarantee that it'll hit negative 4. But is it possible if we look at it through the lens of MVT? Okay, so if you take a look here, what if I compared this point and this point, negative 5 comma 10 and negative 3 comma 2. If I found the average rate of change, 2 minus 10 over negative 3 minus negative 5, I get negative 8 over positive 2, which is negative 4. This is my average rate of change. I found at 2 points of my curve, the slope of that secant line is negative 4. So am I guaranteed a moment where the tangent line or the derivative will be negative 4? Yes, as long as MVT works. Okay? So MVT is only going to work if it's differentiable and continuous. Okay? Notice how they mentioned that G is differentiable here. So it's enough to say that by MVT, there exists a moment where this is going to happen. But make sure that you're showing the average rate of change. Okay? And that's it.